After learning all the concepts, we will start checking the answer in our practice example. Let's look at the first question. Which of the following statements concerning the Brownian motion of the smoke particles are correct? Firstly, the Brownian motion is caused by collision between smoke particles. This is wrong. It should be between the smoke particles and air molecules. Next, air molecules are moving randomly in all directions. Yes, this is the assumption for ideal gas. The mass of air molecules is almost the same as that. That is wrong. The mass of air molecules should be a lot smaller than the mass of the smoke molecules. Or otherwise, the smoke molecules must be moving very quickly because it is being collided by the similar mass fast-moving air molecules, which is impossible. And at the same time, the air molecules are invisible because it is very small, very light, while this is visible. That is why we see mass of air molecules must be smaller than the smoke molecules. This is also wrong. The answer should be boy. The next one. Which of the following statement about the experiment for Brownian motion with smoke particles correct again? The motion is caused by collision between air and particles. Yes. And next, the experiment make it possible to see the motion for air molecules. That is no. In fact, we indirectly conclude the motion of invisible air molecules by the motion of the visible smoke particles. Lastly, the motion is irregular, that means random, because air is a mixture of gas and the molecules have different masses. In fact, no, it is because of the random motion of air molecules. This is the reason. So that the answer should be dot here. Next, which of following is not a basic assumption of kinetic theory of ideal gas? The assumption of ideal gas, then you really have to focus on the assumption here. 5 assumptions. All molecules are in random motion. Yes, this is our assumption. All molecules move with same speed at certain temperature. This is wrong because it is a distribution. The speed and also the number of molecules is in a distribution, so that you got some fast, a lot of average, and some slow molecules, and they are always colliding each other, so that their speed will be always changing. All molecules are point particle, no physics size. Yes. Collision perfectly elastic. Yes. All molecules do not exert force on one another except collision. Yes, because there is no intermolecular attractive force. So that the answer is boy here. And lastly, this is an explanation question. Now make sure you try to focus on the exact wordings of it. Then we are explaining in terms of molecular motion how gas exert a pressure on the inner surface of the container. And we got 2 marks here, so that we got 2 points. Then we have to mention gas is moving, the air molecules are moving randomly and colliding with the wall of the container and rebound elastically, and therefore resulting in a change in momentum. Has create a force, hence a pressure on the wall of container. Again, we have to have all those physics terms here, moving randomly, colliding with the wall of the container, and then rebound elastically. And then we have a change in momentum which created a force, which created a pressure on the wall of the container. 2 marks here.